Alright, today's notes will cover the 6 trig functions of 3 angles we're going to call special angles. And then after we do that, we're going to look at how to draw an angle in standard position and just general thoughts on angles. Alright, there are 3 angles we're going to call special angles. Those 3 angles are 30 degrees, 60 degrees, and 45 degrees. Those are our special angles. We have to commit to memory the 6 trig functions of each of these angles. We have to have it memorized.
There's
no
6
way
for
around.
each.
6 for each, so that means 18 total. But to get those 18, we only have to know 3. If you can know 3 of the 18, you can
We
get
have
the
to
rest
know
of it.
18, but just kidding, you only have to know 3.
Okay.
So confused.
So I'm going to show you how to do that. Now I'm going to go through some diagrams up here to show you how we come up with these ratios. You do not have to write that down. The only thing I want written down is when I do the actual 6 trig functions for each angle. That's what you need to have written down. So when I put these diagrams up here, you do not have to write the diagrams down. It's just showing you how we come up with these 6 trig functions. Now again, what is a trig function? It's
Ratio.
just a ratio, so keep that in mind. Alright, 30 degrees. To get 30 degrees, we're going to start with an equilateral triangle. If I'm dealing with an equilateral triangle, what am I dealing with?
Equal angles, equal size.
Equal angles and equal sides. And if it's equal angles, what is each angle? 60. How do I come up with 60?
60 times 3 is 180.
60 times 3 is 180. 180 divided by 3 is 60. So if I'm dealing with an equilateral triangle, that means each angle must be 60. And we're going to go ahead and label each side as 2. So we're going to label each side as 2, and all of my angles are 60. Again, you do not have to draw this. I'm just wanting you to see how we come about finding our 6 trig functions. Now, if I think in geometry you call it a perpendicular bisector. What's a perpendicular bisector? Alright, I'm going to bisect this triangle in half. So if I do that, the top angles are now what? 30. And that bottom angle is now what?
9.
A 90-degree angle. So that's 90. My top angles are 30. Now, what about the sides, the 2 new sides I have at the bottom? They're both 1. So both of those sides down there are 1. So now I have the triangle I want to deal with, and from that I can find all 6 of my trig functions. But there's one more thing I need to know about my triangle. What is that one more thing? The bottom side. And how do I come up with the bottom side?
1 squared plus b squared equals 2 squared.
Alright, so I use Pythagorean theorem. When we use Pythagorean theorem, we find out that that third side is the square root of 3. So that's how we get that. Now I'm ready to find my 6 trig functions. This is what you want to write down. I'm ready to find the 6 trig functions of 30 degrees. So in order to find my 6 trig functions, what do I have to identify?
Hypotenuse.
I need, well, I'm thinking just all my sides. So I'm using 30 degrees, so I need to know what side is 2. Hypotenuse, what side is 1. Opposite, and what side is radical 3. Adjacent. So I need to know what those sides are to be able to find my 6 trig functions. So if I start with sine, what's the definition of sine? Opposite over hypotenuse. So that makes it 1/2. What's the definition of cosine? So that makes it radical 3 over 2. And once I know what sine and cosine are, do I need my triangle anymore?
No.
No. What does that make tangent? 1 over square root of 3, and then how do I get the other 3? Reciprocal. 2 over radical 3, and radical 3. So how many things do I need to have memorized to be able to produce those 6?
2.
2. I need to know what sine of 30 is, and I need to know what cosine of 30 is. If I know those 2, I can produce the other 4. Questions all on my 6 trig functions of 30? Alright.
So those are always
Always.
wait.
Sine of 30 is always 1/2. Always.
Oh, that's why there's the star there.
Well, it's there because those are the 2 things I need to have memorized to get the other 4. If I know those 2, I can get the other 4. But yes, sine of 30, no matter how big my triangle is, will always give me a ratio of 1/2. Sine of 30 always gives me a ratio of 1/2. Yes.
So you need to memorize sine, or you need to memorize sine of 30 equals 1/2.
Sine of 30 equals 1/2. And cosine of 30 equals radical 3 over 2. That
Always.
needs to be memorized. Always. That is always the case. When I hear sine of 30, I need to be thinking about the fraction 1/2. All right, let's get to 60. 60, I can use the same triangle. I can use the same triangle because it has a 60-degree angle in it.
Yeah.
However, my sides
Yeah.
are going to change. There's one side that will remain the same. Which side is that?
The one.
Two.
The hypotenuse didn't change. Okay, but now what is my opposite side?
Radical 3.
Radical 3 is my opposite side, and what is my adjacent side? 1. So, sine is opposite over hypotenuse, so now sine of 60 is what? Radical 3 over 2. And cosine of 60 is going to be 1/2. Then once I get those two, I can get the other 4. Tangent's going to be radical 3, take the reciprocals. And there's that. And technically, I don't have to memorize anything new to get these 6. What do I need to notice?
That they just like kind of switch.
Say it again. Sine and cosine are switched from what? Sine and cosine of 30. So I need to realize that sine and cosine of 30 are switched to get sine and cosine of 60. So there's really nothing that's new that I need to memorize. I just need to know that sine of 30 and sine of 60 switched to get sine of 30 and cosine of 30 are switched to get sine of 60 and cosine of 60. Am I with me there? So far, that's 12 items, and I only have to memorize how many things?
2.
2. I only have to have 2 things memorized so far. All right, let's move on to 45. To talk about 45, I need a new triangle. And if I'm dealing with a triangle that has a right angle in it, what type of triangle is going to produce another angle that's 45? Somebody said. It's going to be an isosceles triangle. Because if I have one angle that's 90, and it's an isosceles triangle, those other 2 angles have to be 45. Because the other 2 angles have to add up to 90. So if I'm dealing with an isosceles triangle, so my other two angles there are going to be 45, and we're going to label the 2 sides as 1. If I know those 2 sides, how do I get the third side? Pythagorean theorem. So that side is going to be radical 2. So now I'm ready to get all 6 trig functions. Now, does it matter which angle I look at to find my 6 trig functions? No, why?
Because they're the same.
Both angles are the same, so it doesn't matter. So what is sine of 45 going to be? 1 over square root of 2, correct? What's cosine going to be? 1 over the square root of 2. Tangent? 1. And then the other 3, radical 2, and 1. So how many things do I need to have memorized for this one? 1. I need to know sine of 45, along with the information that sine and cosine of 45 are what?
The same.
The same. So my 3 things I need to know to be able to get all 18 are
Sine of 30 is 1/2.
sine of 30 is 1/2,
Cosine of 30 is radical 3 over 2.
and
The sine and cosine of 60 is switched from the
Alright.
sine and cosine of 30. And sine of 45 is 1 over radical 2.
very good. So that's what I need to know to be able to fill out my 6 trig functions for my 3 special angles. Yes.
So when you said we need to memorize them, so the numbers are going to be different?
No.
No.
Always.
Sine of 45 is always 1 over radical 2.
Okay.
Always.
It's always
Now, we're going to fill out a worksheet daily until we have all these memorized. And I'm gonna show you what this worksheet looks like, and then I'm gonna pass it back to you. But I'm first gonna show you how you need to fill it out. So this is what you're gonna get, and you're gonna have to fill this out. So we've got the 6 trig functions for 30, 60, and 45. So the first thing you're gonna do when you get this is what?
Fill in the formula.
Fill in the 3 things you need to have memorized. So what 3 things do we need to have memorized?
The
Sine
sign.
of 30 = 1/2.
1/2, radical 3 over 2, and 1 over radical 2. That's the first thing you're gonna do when you get this paper, is write those 3 down. If you can write those 3 down, then the rest should be easy to get. So let's go back to the top. Tangent is,
1 over radical 3.
so then this is radical 3, 2 over radical 3, and 2. What do I do to get started on 60?
It's switch to the sign.
Switch these 2. So radical 3 over 2,
1/2.
1/2. So I take the tops, gives me radical 3. Take the reciprocals, gives me that. Then down here, what do I need to remember?
That's the same.
These 2 are the same.
1.
I take the tops, which gives me 1. I take the reciprocals. It gives me that.
So, the sine and the cosine are always the same, always.
What do you mean?
I mean at 45.
Yes. And it's always 1 over radical 2. Because again, what is a trig function?
A ratio.
It's a ratio. Okay? So if I go back to sine of 30, what do I know about a triangle that has an angle of 30 degrees in it?
Wait, what did you say?
If I'm talking about sine of 30, what does that tell me about my triangle that has an angle of 30 in it?
Hypotenuse is 2, or ratio 2.
Its hypotenuse is twice the opposite sides. No matter how big my triangle is, any triangle I draw, no matter how big it is, if I've got a 30-degree angle in it, what do I know about this side and this side? This side is always going to be twice what this side is. Because the ratio of it must produce what? The ratio must be 1/2. So, if I've got a triangle that is 30, and I know this right here is 5, what does the hypotenuse have to be?
10.
It has to be 10. Because the opposite over the hypotenuse has to be able to reduce to 1/2.
I feel like this is much easier learning it in this class than geometry.
So if I go the other direction,
The extra 3 is a
if I've got a 30-degree angle there, and let's say that is 40, what do I know about the opposite side?
20.
It's 20. It doesn't matter. The ratio of the opposite over the hypotenuse, if I'm dealing with a 30-degree angle, must always be 1/2. Okay? Always. Question?
It was always just radical 2.
Yeah. I remember.
I
think that was the equal lateral one.
Alright, so that's your special angles. That's what you're going to have memorized. And let me pass out that sheet that you're going to have to give me. So this is the sheet you're going to have to fill out. If I were you, I'd go ahead and do it real quick. See if you can fill it out on your own. While you're doing that, we'll get set up for our next part of our notes. But these are not, this is not hard to fill out. Okay? You are not trying if you can't fill this out for me.
Coach White, I know this is really random, but is Thanksgiving always on like a certain date, or is it
Always
The
on
last
Thursday.
Thursday.
Last
It's always
Thursday.
on Thursday.
What it is?
Hang on to it.
Okay.
I just wanted you to practice what you're gonna have to do. We will start doing those on Monday.
I nailed it.
So when you show up on Monday, get ready to fill one of those out.
What do you want me to do?
Let's go.
Alright, next we wanna talk a little bit more about angles. We wanna kinda build on what you guys know about angles so far. What do you guys remember about angles from geometry? Just anything that pops out.
Complement to it is what equals 90.
Alright, we got complementary angles, or angles that add up to 90.
Supplement.
Supplementary, they add up to 180.
Linear
Vertical
pair.
angles are always the same.
I was, oh, just.
Okay, I know what you're talking about. Okay.
Linear pair, they're the same.
Thank you, dude.
Or I mean, they add up to 180 or something like that.
Say that again.
A linear pair of angles. That's
Okay.
Equal 180.
Alright, so that would be similar to like supplementary angles.
In a triangle, if you have extending, I guess it follows the same rules. Like if you have an extending line and you have the angle of outside, just subtract
Those-
it from 180.
Right, those two have to be supplementary as well.
Opposite interior angles are the same, opposite exterior angles are the same.
Okay, now what was the biggest angle you guys dealt with in geometry?
Just the line.
180? 180 was the biggest angle?
Yes.
Okay. See, when we get into trig, angles can be as big as we want them to be, and they can also be as small as we want them to be. Okay, angles can also be negative angles. Okay, so I just want to know what you guys know already to build on what we're getting ready to look at. Okay,
Might as well just teach it all.
so
This will just be teaching.
this is what we're going to look at mainly today. We're going to look at parts of an angle, look at degrees, and maybe sketch an angle. We'll get to the rest of it on Monday. And again, number 5, we already talked about number 5, so we're probably good to go on number 5. You should know what complementary and supplementary are. But as far as some of the other ones, we'll start it today and get to the rest of it on Monday. All right, parts of an angle. There are like 3 to 4 main parts of an angle. All right, and this first part is called the initial side. An angle is made up of 2 rays, and the first ray is called the initial side. The other ray is called the terminal side. Okay, those names should make sense. Initial means where I'm starting, terminal means where I'm ending. So it should make sense that my initial side is where I'm starting, the terminal side is where I'm ending. Okay, the place where these 2 rays join, what do you think that's called? What'd you say? Vertex. Vertex. And then the part about an angle that may be new is we have to show rotation. You have to tell me which way this angle is rotating. So I would show rotation like that.
Why can't it be the other way?
Well, I'll get ready to tell you.
Okay.
Okay, there are 2 types of rotation. What type of rotation is this, do you think?
Negative.
This is a counter. Counter rotation is positive. A clockwise rotation is negative. So if my angle is rotating counterclockwise, it is a positive angle. If I'm rotating clockwise, it is a negative angle. So we're going to start at the initial side. We've got a terminal side. We've got the vertex, and we're going to show rotation. So, another way to draw this, instead of that rotation, I could have shown this rotation. What type of angle does that one produce?
Negative.
That one produces a negative angle. Okay? But what would be the same about these 2 angles? I've got a negative angle here. I've got the positive angle there. What's the same about those 2 angles? The initial side and the terminal side are still the same, but the rotation is different. Okay? You're going to have to draw angles for me. You cannot draw an angle without showing me the rotation. If you don't show me the rotation, I don't know if it's positive or if it's negative or how big it is. Yes?
Do you have to do both, or can you just pick one?
No. I'm going to give you I'm going to give you a degree, and you're going to have to draw it for me.
Okay.
So you determine
Yes, you'll have to decide, depending on what angle I give you, whether or not it needs a clockwise rotation or a counterclockwise rotation. Okay, question so far?
I still don't get that part where you said it can go either way, or like how they were different. Like which one? How do you know if it's clockwise or counter?
Depending on if your angle is a positive or a negative angle.
So it'll like tell
Oh.
It'll give you an angle, and then you'll have to draw it.
you. Oh.
When you say negative angle, will we literally put like a negative in front of the number or whatever it is? So what if it's just a straight line?
Straight line.
A straight line that's 180.
So if I have my initial side here, and I've got my terminal side there with my vertex in the middle, is that what you're asking? Then you've got to show me either that rotation or that rotation, depending on if it's a positive 180 or if it's a negative 180.
How do you know that side's not your initial?
Because the initial is always on the positive x-axis. We're getting ready to talk about
Oh.
Okay.
that. Okay? So that was just to show you kind of the parts of an angle. Now we want to show you what you have to do to draw the angle. Your initial side must be over here on the positive x-axis. Okay? So I think about the x-axis as two parts, the positive x-axis and the negative x-axis. The negative x-axis is on the left side of the y-axis, and the positive x-axis is on the right.
so anything just going that way.
Yes. So my initial side must always be here. The initial side is always in the same spot. It doesn't change. On any angle, the initial side is always in the same spot. The thing that's different is my terminal side. Okay, so I've got my initial side, I've got my terminal side, and then you have to show me the rotation. Right now, the way this angle is sitting, I don't know how big this angle is because I don't have any rotation. Okay, I don't know if it's a positive angle, I don't know if it's a negative angle, I don't know how big it is. You've got to show me rotation. So if I wanted a positive angle, you would show this rotation. If I wanted a negative angle, I would show that rotation. Okay? All right. Now, we're just going to talk about degrees for right now. If I'm starting out over here on the positive x-axis, what angle do I have if I haven't gone anywhere yet? 0. So I'm there at 0. If I'm straight up, how big of an angle would be straight up?
45
What?
45
90. 90 would be straight up. If I'm all the way over here to the left, 180. And this is where we get into new territory once we go past 180. What's my angle going to be down here? 270. How am I getting from one to the next thing? What am I doing? Adding 90. So if I add 90 to 270, what am I going to be back at?
360.
360. Okay? Now, you can keep going. We don't have to just stop if we're one time around. I can keep going. So what would my next angle be if I kept going? 450. So I could have 450. I could then have, what would that be? 540, and so on. Okay? So if I were going to show a 540 degree angle, I would have my initial side there. I would have my terminal side there. But what am I going to do to show it's a 540 degree angle? I'm going to go all the way around, and then I'm going to end up back there.
Oh.
So that shows, that's how you do an angle that's bigger than 360. You just keep going until you get to where you want. Okay?
Oh my god.
We didn't get excited about it.
Oh my god, now I want pink swirl because it looks just like this swirl, like I just saw it.
Because if they just said, if they wanted me to draw a 540, is that what you're asking me? Because I need to know that one time around is 360, and then each time I go to do a thing, I just add 90.
Oh my god, I'm dizzy.
Right. Yeah.
So if it was gonna be a 450, would the terminal side go up?
Terminal side would be it. All right, now, if I'm going to do a negative, if I've got my initial side there, and I'm going to do a negative, what would this be here? What would I call this now?
270.
No,
$9.90.
negative 90.
Gosh.
Okay, if I wanted to draw it to here, what would that one be? Negative
So
180.
big.
If I wanted to keep going to there, what would it be? Negative 270. And if I wanted to keep going to there, negative 360. Okay, and I can keep going. Okay, there's no limit to what I can do, how big or small the angle is.
It's like swollen, but it's not.
They'll tell you what angle, yes. Okay, so here's an example of what you're gonna have to do. They're gonna give me an angle like 210 degrees. And they're gonna want you to draw it. So we always start out drawing my initial side. And then the next thing I have to do is figure out where my terminal side needs to go. So I need to figure out what quadrant 210 degrees is gonna end up in.
3.
3. How do you know that, Roshan?
Well, I mean, 90, 180, and then it'll be.
Alright, so I know right here is 180, and I know down here is 270, so that means 210 has to be in between those two, correct?
Yes.
Is it gonna be closer to 180 or 270?
180.
It's gonna be closer to 180, so when you draw it, we wanna draw something that is closer to 180. And I'm not done yet. What do I have to draw? What do I have to do before I'm done?
Rotation.
I have to do the rotation. So if I'm gonna draw 210, I've gotta show my rotation today. If I don't show rotation, I don't know if it's a positive angle or a negative angle or how big it is or how small it is. I've gotta show rotation.
I kind of like this.
Alright, let me see if I've got one more. We'll do one more example, then we'll be done. Okay, this time we wanna draw negative 300. So again, we start out with our initial side, always in the same spot, positive x-axis, which would be right there. Yes,
So that's not showing that the top is negative 300. That's just saying.
that's saying draw negative 300.
Okay, because I was like, I don't.
Yes, that's not saying that straight up is negative 300.
That's why I did this.
Alright, so I need to figure out what quadrant negative 300 is gonna end up in. What do you guys think? It's gonna end up in 1, because I've got negative 90, I've got negative 180, I've got negative 270, and negative 360. So it's gotta be in quadrant 1. Is it gonna be closer to the vertical or closer to the horizontal? Closer to the vertical. So we will draw this right here. But as of right now, I don't know if this is a positive angle or a negative angle, so what do I have to show? Rotation. And since it's negative, that means I've gotta have clockwise rotation. Once I do that, now I know which angle I'm dealing with.
So when it's negative, you just like switch the numbers and they'll, like instead of going this way, they'll go backwards.
Yes.
Okay.
So instead of 90 being on top, 90 is gonna be on bottom.
Okay.
And it'll be negative.
Can you have a negative 0?
Nope.
So what would that side be?
Zero.
This one?
Yeah.
This would be
That's
negative 180.
negative.
Zero.
90, negative
0 is always right there.
70, and 0.
So 0 just stays the same.
0 stays 0.
Oh.
0 cannot be positive or negative.
Okay.
Oh.
Alright, so that's a start into dealing with angles. We'll finish that up tomorrow and get to those other things that were up here on our list. Right now, let's go ahead and get yesterday's assignment out. We'll look at a couple questions and get it checked off.